so if I can have everyone just turn off their monitors and just spin to the front here so you can take a look. So I can just have your full attention as I get started on the content here. You're going to be right back on the computers when we start the example. So here's the little Super Mario demo that I did in the last unit, based on the units that this course has. So we started with programming basics. Well, we started with like the intro to computer science, which had us look at problem solving and some of the basics of that. But programming basics was just us getting started. And I know it's hard to see on there, so let me just zoom in real quick. The basic code you needed to know in that unit was just that. The object dot property equals a new value. So you guys may remember back this. Image happy or pick happy dot visible equals true. That was some of the first programs you did. Pretty simple, but it came up with that basic concept that we can use code to affect a change in what the user wants. Okay? From there, we then moved, after doing some programming in that unit, to variables. Okay? So in variables, we were basically using the computer's power of its ability to remember stuff, its memory. Okay? There wasn't a lot more we could add to that, but the ability to make a variable was an important piece of what was to come, as you now see. So variables basically had just this line of code that you needed to know. Okay? That you had a variable type, and then you gave it a name, and then you gave it a value. It was very similar to the one we had just done in the one before, but now you were creating something new. And in variables, you saw your first like blue piece of code, which meant that's a reserved word, like int x equals 10. Okay, that was you making a variable. Okay, then in our last unit, conditional statements. Come on, Mario, move up. Ah. Why is it drawing? Let's try that again. So then Mario moved up. Okay. So in conditional statements, we started looking at how we could structure our logic a little bit better. So the code wasn't just running every single thing that we wrote down. It acted as a control, okay? And I'm not going to zoom in on that, but basically it was the basic if statement. And if also was in blue because it was a keyword, but now we were adding things like brackets. And the code got a little more complicated in the way you structured it. But now you were hopefully warmed up, having done the previous units, to the idea of what code was. The jump up to looping probably wasn't as big because a loop looks very much like an if statement, except now the logic is letting the computer run things in circular logic, like over and over again. And we get the idea that it's a machine, so it can do the same thing over and over again quite a bit. We've talked about where we're going to go from there. We're going to squeeze in some extra stuff. And that falls into two categories. Stuff that you think you're going to need for the future or didn't learn, and then stuff that looks ahead at where coding would go if you were to take computer science beyond this grade 10 intro course. And that jumps you up to your final project, getting the course done, right? In the end, you want to be able to build something that you feel you've been able to master through these basic programming introduction constructs, okay? Some of this might require you guys to dig deep ahead. It depends on where you're currently at. If you're kind of still struggling with grabbing some of these concepts, if you're still back here somewhere, then yeah, the extra unit won't be something that you're going to engage in that much because you're just trying to grab the basics, right? This will kind of depend, and what kind of project you do will also depend on how well you've mastered these things. So for example, if you're still down here, just learning variables, the type of project you can do is limited. Okay? You can't do maybe a fancy game if you can't master some of the concepts that build towards that. Okay? Some of you might have really big, grandiose ideas for your final project, which means you're absolutely going to have to master all this stuff, and possibly more, right? Depending on how deep you want that rabbit hole to go. So that's the idea, right? That's the idea of where we want this to be. And it leads into, whoops, what we're going to do now, which is moving ahead with looping. Okay? Whoops. Start that from the beginning again. There we go. Okay. So, looping. So you previously, when I started looping, said there would be two types of loops. The one that we've already done is what's called the event control loop. It's the while loop. You don't know when it's going to stop. Now, you can use a while loop to do counting, which if you've done some of the programming problems in this unit, it kind of does already. If, for example, in the second programming problem, it uses a while loop to do counting. But what I'm going to teach you today is a loop that is designed for counting. It's specifically designed to do counting. It's known as the for loop. Okay, so it uses the word for, F-O-R. So the first thing about this loop is it's not as intuitive. Like the while loop will probably make a lot more sense to you because it's kind of how we talk. Not necessarily, but you can at least imagine that you'd say, you know, oh, while I've still got free time, I'm going to keep, you know, playing video games. The word while is used in our regular language. We don't use the word for that way, okay? We don't really do it that way. So the for loop is going to be a much more technical looking loop. It's much more sort of math type loop. So for some of you, it's going to be a difficult loop to write. You'll have some examples, so you can use the examples, but you may not necessarily fully grasp it unless you're kind of at that point. So the for loop, the way it works, is it's built into 3 sections, okay? It uses a variable, and it starts at a certain value, it ends at a certain value, and it changes by a certain amount. This is what counting does, right? If I said count 1 to 10, you'd need to know what you start at, 1, what you end at, 10, and how much you change it by. Do you count by 1s? Do you count by 5s? Right? That's essentially what it is. So it uses the keyword for, it uses curly brackets, and it uses round brackets, but what goes inside the round brackets is a lot more technical. It's not something you're going to see fits naturally. It's just something that's a little more math-based. Okay. So here's an example, okay? So in this example, you say for int I equals 0. That's the starting amount. So I starts at 0. Well, I is less than 10. That's its ending amount. So it keeps going while it's less than 10. And I++ means I will increase by 1 each time through the loop. So that's a very simple example of what the for loop looks like, okay? It's tricky though. It's tricky to kind of analyze this. So let's kind of look at some of the pieces of this loop. So the variable I, it's very math-like to use I, but that's actually pretty common with for loops to use a variable called I. I is actually short for iteration, which is just a fancy word for loop, okay? And you could use something else though. You don't have to use I. You could use count, counter. You could use X if you wanted to. But I'm just going to say to you that I would recommend you use I, because anytime you go on the internet and look up for loop, chances are the example you're going to find uses I as the counter variable. Then it's set to its starting value. In this case, I started at 0. I don't have to start it at 0. I can start it at whatever I want, okay? Every time through the loop, it keeps checking, is I less than 10? Is I less than 10? So that's what it checks by. And then I++ is just shorthand. We learned that in part 1, that I++ means the same as I equals I plus 1. And you could write that there too. You don't have to write I++. It's just shorthand, okay? Now, what's also interesting about the for loop is the variable I is created right inside the for loop. Like it's built right in there. So I don't need to make the variable before the for loop starts. Whereas with the while loop, I kind of had to do that. I had to make the variable first and then go into the while loop. So the I variable is made right inside the for loop itself. Okay? So the basic structure is this. It has a start, an end, and an amount. In the middle between start and end here is 2 semicolons. So again, that's a weird sort of structure of the for loop, that it has semicolons there and there. Then inside whatever you want your code to do inside of a for loop. Okay? It is trickier. You can write any single for loop as a while loop, and actually vice versa. So if you find the for loop tricky to work with, when you get to something like your final project, my advice would be, don't use it. Use the while loop instead. Okay? They can both do the same thing, just the for loop is designed for counting. Okay? So if you're not feeling comfortable with the code, then use the other version. Use the while. Okay? All right. Now, because it has this structure of, let me go back, start, end, and amount, I can vary this, right? I can have it start at whatever I want. I can have it end at whatever I want, but I can also change the amount. The amount doesn't have to go up. It can actually go down, okay? or it can go up by different amounts. So here's an example of a for loop that starts at 10, goes to 100, but it says less than or equal to 100. Whereas if you go back to the one I had up here before, notice it says less than 10. So this loop would go 0 to 9, because it couldn't go to 10 because 10 is not less than 10. So it would go 0 to 9, which is a weird way to count, but that's how it would go. Now this one, let me move ahead, would go 10 to 100 because it says less than or equal to 100. But notice what it changes by. I equals I plus 10. So this thing would count by tens, not by ones. So if I ran this code with the message box, it would do this. It would go 10, 20, 30, 40, 50, all the way up to 100, counting by tens, okay? So that's one variation on the for loop, is because it's good for counting, you can just play with the math a little bit and have it count in different values. So in this example right here, I have it going this way. I say I starts at 5, keep going while I is greater than 0. Not less than 0, greater than 0. Well, 5 is greater than 0. But notice what I do on the way I change it. I have I subtract 1 each time. So this is a countdown loop. This loop would go 5, 4, 3, 2, 1 instead of 1, 2, 3, 4, 5. So you can use the for loop to count backwards as well. You can have it count backwards by tens if you wanted to. You can just muck with the math there a little bit to change the way it works. You can use shorthand, as it says here. You could say I minus equals 10, which means the same as I equals I minus 10. You can even do fancy things like I equals I divided by 2. You can have it keep dividing itself in half each time through. So the for loop is tricky, but it's another tool in your programming toolbox that allows you to write code to do what you want it to do. Again, if you find it difficult, there's an alternative. You could use the while loop, okay? If you're finding looping difficult, you should still be mastering conditional statements and things like that, like I was showing at the beginning. Okay, that's it for the content of this unit. But now I want to throw in some bonus stuff. And I know I'm calling it bonus, but I know some of you are going to want to know this stuff, especially if you're thinking games for your final project, okay? So for example, we're going to start looking into graphics now. In the example today, we're going to do something graphical, okay? Now, I know you've been doing some graphics. You've been drawing pictures. But you haven't actually making the programs draw the graphics themselves, right? So we're going to take this idea of graphics and combine it with the idea of the 3 core constructs, variables, conditional statements, and looping, to come up with stuff that's a little more creative, okay? So here's some example of objects that maybe you haven't used yet in the toolbox. So stuff like the numerical up-down, and we're going to use this one in the example today, that allows you to change, instead of a text box, allows the user to type numbers and use the little up-down arrow keys. Today we're going to explore, for example, the color dialog and the tool strip dialog, okay? So we're going to be exploring things that maybe you haven't touched since way back in that first design assignment, okay? So the color dialog, for example, is going to bring up this dialog box. You've probably seen this in other programs. Your program is going to have this today. It's going to have this thing where the user can choose a color. Well, that's pretty cool, right? So I can actually choose a color in my program, okay? And the tool strip is us building a toolbar on our programs. I mean, up to this point, you've just used buttons on your program. But, you know, like a lot of programs like Word and Photoshop, they use a toolbar at the top. So let's do that with our program today. Let's try and incorporate that, okay? I'm not sure if it's in our example or it's in one of the assignments. I can't remember. But as well, I want to start touching on some of the little more advanced coding concepts, okay? So for example, there's a concept that you'll learn in grade 11 if you take the course called a class. A class is a way to organize your code to the next level, okay? It's a big concept studied in grade 11. As a matter of fact, in my morning class, just during period 1, we just finished this unit this morning, okay? It's a big concept. It's similar to what I did back when we first started programming. Whoops. You may remember I put this bench up on the table here and I said, oh, this is a thing that has properties and functions. You can talk about things it can do and things about it. Well, that's actually what that classes unit goes further into next year, okay? All right. We actually have seen this code. You may remember this code back at the beginning. font equals new font, and then you'd have this thing like this, okay? Or random equals new random. These are very similar lines of code. In the example today, you're going to see a line that looks like this. Pen equals a new pen. So we're going to actually be creating a pen object that can draw on the screen. And it'll say, oh, it's going to be a white pen, and it's going to be 1 pixel in size. And we're going to do this. Form border style, none. So we're going to actually be able to change things about the form. This is that concept again. It's this concept of something simple that we do here in grade 10 has a much bigger background to it. And I'm just touching on it right now, okay? So some of you get intimidated by this. You see a line of code like this, pen equals new pen, and you think, I don't understand what that line of code is. And you shouldn't really at this point, okay? So when you're learning coding, sometimes you just mimic the code. You go, oh, I'll just use this example, put the code in, and mimic it. I don't fully understand what it is, but I can use what the example, that's okay. What I'm saying is that's fine if you're doing that. I'm not saying it's fine if you just copy off somebody else. I mean, that gets the assignment done, but it doesn't actually help you learn anything, right? So when you get to your final project, you're like, oh, I don't know how to do this. Well, yeah, because you didn't learn anything, right? But it's okay to mimic code and then modify it. So it's again this idea of properties, functions, using the dot, which we learned way back in the beginning. And you're going to see some of this today. You're going to see things like create graphics, color.white, color from RGB, surface draw an ellipse. You even saw this back when we saw convert .2int32. Some of this you've seen before, and you've either just mimicked the code to make it work, or you thought, you know what, it kind of makes sense what it's doing. You don't need to have a full grasp of code to at least work with it sometimes, okay? That being said, in my grade 11 course, I strip away all the sort of smoke and mirrors. We dive into exactly what that code does, right? So the grade 11 course takes away sort of the mystique of that, and it dives into the deep details of that. All right. So now we look at graphics, right? So if you think about the way graphics work, okay, and let me just ignore this screen for a second, jump over to Smartboard for a sec. Okay, so you guys know from your training in math, the Cartesian geometry system, okay? You've been taught it for a long time now. You know that there's these two axes, right? You've got your y and you got your x. And if I put a dot right there, okay, you could measure how much x value it has, right? And how much y value it has. And you know from math class that mathematicians will write that as an ordered pair, x, y. Well, that's a very good system of putting something in a place. Well, computer uses the same type of system, okay? If this was a game, and I was going to draw a little character on my game, so say my character was going to be right here, okay? I would need to plot what x and what y it would go at, okay? But how does it work, right? So let's say this is my computer screen right here, okay? If I'm going to plot something right there, how do I figure out the x, y? Okay? Does a geometry system go like this across my screen? That would be a good guess. And in some programs, simple programs like Scratch, that's the way they do it in Scratch. But that's not the way most high-end programming environments work. They don't plot it that way. What they actually do is they take this system and they move it up to here, okay? So in other words, if I go back, let's see what you guys know from math class. Does anyone know what this spot right, here is called? It has a name. Someone said it, origin, right. And what's its coordinates? 0, 0, right. That's the origin point, 0, 0, okay? You're right. Now, moving ahead. Let me draw this a little bit better. Let's say this is the screen. This is the screen. The origin point, 0, 0, is right here. That is spot 0, 0, the origin point, okay? So if I move this way, I'm increasing which axis? I'm going this way. X, right. So this is where X is getting larger. So I move this way. But what would you think would happen if I'm going this way? Y would go negative. Yeah, that's the way you would do it in regular math. But on the computer, they flipped the Cartesian system on the y-axis. So if I was to plot a point right here, it might be at around X at, say, 100. Say that was spot 100 right there. And the Y would maybe be around 80. Okay? It wouldn't be negative 80. It would just be 80. Okay? So that's the way it plots things. So now that you have this idea that that's 0, 0, and I'm going to put something right here, what if I wanted to draw a rectangle right there? Well, the way it would draw a rectangle is it takes that particular XY spot and then uses that as the top left corner for the rectangle. It's always going to use the top left corner. But then what else does it need to know to draw that rectangle? Well, it needs to know two other things. What's its height and what's its width? If it has those four numbers, if it has X, Y, the height, and the width, it can draw a rectangle on the screen. It can also, if it wanted to draw, say, a circle or an ellipse, it can start with the rectangle, and then it can draw an ellipse inside the rectangle. Okay? So basically, the rectangle is the basis for drawing basic graphics. Maybe some of you have heard this before. It's often called the bounding rectangle because it bounds around that thing. Some of you call it, if you're into gaming, call it a hitbox, right? Have you ever heard that expression? A hitbox, right? It's really not a box. It's a rectangle. It's a hit rectangle. And it's sort of a rectangle around the object that it's drawing at that point. Okay? So this is going to be important if you want to do games because not only can I draw it here, but if I start changing these numbers, if I start making one of them go up, what's going to happen to that shape? It's going to move. It's going to move on the screen. And then if I get to something like, oh, now it's moved all the way to here, I should have some code in here that says, oh, if the X value gets too big, go the other direction. So it would rebound, right, and stuff like that. So all that stuff obviously gets super important as you start thinking about your final project, yeah. So this idea of the math that you know in geometry and the x, y coordinates and drawing things from an origin point and then moving things starts to become more powerful when you combine it with the code you've learned. And we're going to do this today, okay? So everything I just talked about is on here as well, that the upper left corner is the origin point 0, 0, okay? And that when it draws, for example, at spot 46, 44, right here, it then uses that as the top left corner of drawing the rectangle for whatever it's drawing. For example, a button. Okay? By changing those x, y's, and by the way, you can do that with your properties window, right? You guys know that you can draw a button on your screen using your mouse, but you can also just do it with the properties window. You can actually change the x, y, and the width, height right there in the properties window. Okay? And you're going to see we can do it in code too. Okay? All right, you guys ready? Let's get started. The example has a real simple design. It's a form with two buttons and a numeric up-down. Okay? So the design is real simple. Two buttons. Button, button. Just keep them small, just tiny little buttons. A numeric up-down. And then something unique called a color dialog. But when you try to draw the color dialog on your form, it won't show up on your form. Instead, it shows up at the very bottom. You may have remembered this happened back when you were doing the design assignment. So those are the things I need you guys to build. And I need you to name them as well. Okay, name them the names that are up there. I'll build mine, and then we'll continue from there. So give you guys a minute to get that all designed. Okay, so here's what you guys should have. Here's mine. See, very simple design, nothing fancy about it. Don't need to change any properties. And then make sure you have the right names there, right? Button exit, button run, or BTN exit, BTN run, CBD color. My form I called FRM example 2. Now, if you didn't call them these, it's not a big deal. But when you see my code, you'll have to make the adaptation. So for example, if you called yours BUT run, butt run, I know. It's just so tempting to do it that way. But if you did that, when you see my code, make the adjustment. Okay, adapt. Adapt with the scenario. All right. So here's what we need to do. I need you to go into the FormLoad code, which means you double-click an empty spot of your form. Okay? Let me zoom in. So we are in the code called FormLoad. If you didn't name your form, it will say form_load. If you named your form like me, it's going to say whatever you named it _load. Anyone lost? All righty. Let's rock this. So here's the good news. There is no ifs and there is no loops in the code we're going to write in FormLoad. But there is several lines of just regular code, and it's tricky. All right, here's how we do it. We're going to start with the keyword this. You've never seen this keyword before, but this is just a way to refer to your form. You can just say this means me, the form. Dot back color equals color with a capital C, pardon me, and we spell it American. There's no U. Dot black. So this line of code that we just typed is very similar to our very first unit. We're saying this property, this object, the object is this, which means the form, dot property, which is the background color, equals black, equals color dot black. So you don't need to, but if I run this right now, I get a black background. I get a black background color. Okay, very simple. Now I know you could have done that with the designer, but this is part of this is just using the code. All right, here's the next one. This dot form border style. Now here again is where the autocomplete really helps. Because if you didn't use autocomplete and you just type that whole thing yourself, you got to make sure that you're using a capital F, a capital B, and a capital S. Otherwise it's going to give you an error. Now let's assume you're one of these people, because these people exist. You started typing it, and then you lost the autocomplete. It just disappeared on you. A dumb student would go, oh crap, I got to go all the way back to here and then start typing it again. Oh no, I lost it again. What do I do? A smart student knows that if you hold down Control and press spacebar, you can always get it back. Control spacebar always gets it back. Okay? Equals. Here's the keywords. System. Dot Windows. Dot Forms. Dot Form border style. Dot None. Now that was a long piece of code just to do what it does, but you can kind of now, as a programmer, not a beginning programmer, but an experienced programmer, understand that you're saying, I want no border on the form for this window in my system. That's what it's saying. And guess what? If you run this now, you're going to get exactly that. You're going to get a form with no border. None at all. Okay? And I got to hit the stop button to actually stop it. All right, next line. This dot start position equals system, whoops, dot windows, dot forms, so it's the same, dot form start position, dot, and here you can see again the same stuff that you get in the designer, you can get in code. So I'm going to start this form center screen. Okay? So this basically just said, I want to start my form in the center. So now when I run it, it's supposed to go to the center. It didn't. We're not going to worry about it. We're moving on. Not going to worry about it. Well, if you have an error, you should worry about it. Okay? Just make sure that you're getting the right code there. Okay. If that line's giving you trouble, delete that line. It was just an example. All right, now this next one. This dot window state equals system dot windows dot forms. I know it's a long one. Dot form window state. dot maximized. Okay, here we go full screen on our app. Okay, so I wouldn't recommend running it at this point unless you're familiar with how to get out of it once it runs. But right now what we're going to say is that this form is going to run maximized. And because it has no border, here's what's going to happen. It's going to do this. Full screen app, no way to get out of it. Okay? So the way to get out of it is to press Alt-Tab to jump back to C# and then hit stop. But again, I would recommend just don't do that. Don't run it yet. Okay? Because in order to get out of it, we need an exit button. Oh wait, we have an exit button. Let's code it. Take a second to jump to your design and double click your little X button to exit. Who knows the code? Who knows it? What is it? Application.exit. Does anyone know another way? And now I'm glad some of you know that one because you were using the word this, which is the exact word we were just using in the other one. I'd actually recommend the first one, application. Don't use them both. Okay? But some of you have learned this already. You've been exploring, which is excellent. I'm glad to see that. All right. So now, if you run it, it goes full screen, but you can use your little button to exit it out. That's good. We can get out now. We can get out of it. All right. We got a little more work to do back here in FormLoad. We weren't done yet. Here we go. Before we do our work, we need to go and make a global variable up at the top. Remember, global variables are created under the words public partial class, but after that opening bracket. So they're made in here. Okay? This code right here, this thing that's always in there, you don't ever want to touch that. That's code that C# writes, and basically that one thing is what draws your design. So you don't want to mess with that, or it's going to mess it up for you. Okay? But we got to make a little variable up here. It's going to be a constant. It's going to be an integer called spacer. It's how we're going to use things to space things out. And it doesn't really matter what number we put here, but it shouldn't be huge. So I'm just going to use 10 as a round number. Later you can go and change that if you want. But we're going to start with 10. That our spacer is going to be 10. Okay? So we made that global variable called spacer. All right, now back to FormLoad. Let's get into some more code here. We need to figure out the width. So we're going to make a little variable, a little integer, whoops, for the width equal to form example2, that's our form, dot active form dot width. That's how you do it. That's how you pull up the width from the form itself. Now, that's interesting because I'm just getting the width right after I maximized it. So the width of the form right now is the width of the screen. It's the actual width of whatever my screen is. And this will depend on what kind of computer I'm running on, right? If I'm running on a smaller computer with a smaller screen, that's going to give me a different number. I'm going to do the same with height. Whoops, can't spell. Equals form. And again, if you didn't name your form, you should be putting form1 there, right? Whatever you called your form. There's my height. So now I have the width and the height stored as numbers. I'm going to use those two numbers. Let me just show you. To position these three buttons, these three things, on my screen better. Because right now they're over here, and I actually want them way over here, just like a red X should be. So here's how I'm going to do it. I'm going to say button exit dot. Now, you can't just directly change its X or Y value. The way it works in C# is you change its top value, okay? And I'm going to say it's equal to spacer. And then I'm going to say button exits dot left value, whoops, equals the width of the screen. But that wouldn't be very good because then it'll shoot the button right off the screen. So I'm going to subtract, okay, button exits dot width minus spacer. Okay, so it's a little formula here. Let me try to explain it in a minute, but let me just show you what it does when I run it. I'm going to run it, and notice where the x is now. It's right there. Okay? And it depends on what my spacer amount is. If my spacer is 0, just to show you, it puts it as tight in the corner as it possibly can. If I make my spacer 100, notice that it puts it 100 by 100 away from the corner over there. Okay? So that's what spacer does with a little bit of math. Let me try and explain this a little bit better to you guys. Okay? So here's the screen. I'll just draw the screen right now. Okay, so that's my screen. And let's say this is my little X button right here. And we set a spacer amount at 10. This is our spacer. So the first thing I said to my code was, take the top of this button and set it to 10. So it went to this. It said, oh, whoops. Oh, really? Come on. I don't want this all grouped together. Group, ungroup. There we go. I want these two things grouped together. So it said, move this thing up to 10. So it did that. Okay? But then if you look at the next line of code, it says, take the left of this button and set it to the left of the screen. So for a second, put the button there. But then it said, subtract the width of this button. So then it went to right there. But then it said, subtract 10 more. Oh, okay. So that's how it positioned that thing, all in one little piece of math. Okay? So say it was here. It went, set the top to 10, set the width to the width of the screen, minus the width of the button, minus 10 more. And that's how it positioned that thing exactly where it needed to go. It was just using a little bit of math to do it. All right. Let's position button run. Button run. Okay. Dot top. Well, I can't set it to spacer or it's going to overlap over the other button. So what I'm going to do is I'm going to set the top of the run button to button exit dot top. So they're going to line up together for a second. But then I'm going to add button exit dot height plus the spacer. So let me show you what that does, okay, on the diagram here. I know I went a little bit fast with the code here. But let's say this was the other button. Let me just ungroup it for a sec. Delete that. Delete that. So this other button, we've got a little plus sign in. Okay. Whoops. There we go. Let's group that together. So this button, let's say it was right here. It says, okay, where I want you to put yourself is, set your top to the same top as the other button. But then add, so adding means going down, add to that the height of this thing. So it goes to there for a second, and then it says add 10 more. So that's how it's going to work. But remember, this button is still way over here. So I got a little more work to do. I got to do the exact same thing I did up here. So copy, paste, but with button run. Copy, paste is your friend. So now button run uses the exact same formula as button exit. To keep it correct, I probably should use the word button run right there. But let's see how that looks now. Boom, those two buttons are right there on top of one another. There. And again, it's all depending on our spacer. If my spacer was as low as 1, they'd only be 1 pixel apart up the top there, and 1 pixel away from the edge. If my spacer was 0, they wouldn't be apart at all. They would basically be as close as the computer can draw them. Now, it looks like it's still drawing them 1 apart, but that's probably just the nature of those buttons. I'm going to move it back to 10, so it gives it a little bit more space there. Okay, so you're getting the idea now that you can control the position of things using code. Okay, let's do it again. Nud top, nud size dot top equals button run dot top plus button run dot height plus spacer. And then nud size dot left equals, and it's width minus nud size dot width minus spacer. And then we got one more line before we leave this. Actually, two more lines. That numerical up-down, let's set some values for it. So nud size dot maximum. So we will only let the user go up to a certain number. And we're not just going to guess what that number is. We're going to say it's height minus spacer times 2. So double the spacer amount. And then the minimum for nud size is just 1. Let's just give it a minimum of 1. Okay? Whoops, this should say left up here, not leave. Left. There we go. Okay, so let's see what we got here. So now everything is positioned up here in the top corner. I can move this number up and down, but it can only go down to 1. 1 is the minimum. If I really hold this and go up as high as possible, it'll only actually maximize out at the height of the screen. Now, I don't know what the resolution of this particular monitor is. Can you guess? Anyone know what it is? I'm going to find out in a second. It's around the number I'm getting up to, 1030. It's not actually 1030, though, because I've subtracted a little bit. Because I've subtracted 20. So it's really 1050, right? That would be the amount. Okay, does anyone need a second on that code? Okay. Okay, so what I need you guys to do now is we're going to code that plus button, the little plus button. And it's not really plus. This is the button that makes the magic happen. So let's go into the run button. It's just the button that's going to run our code right here. Okay. So we got about 30, not 30, but maybe about 20 lines of code to type here. Okay, not all of them are long. Some of them are short lines. But let's get started. The first thing we're going to do is we're going to do this. Color dialog box color, CDB color dot show dialog with an opening and closing bracket is going to be the first line of code that we're going to do. Okay? I'll show you what that line does. When I run it and I click the little plus, this will appear on my screen, the dialog color chooser. And I can even expand it out to this format if I want, right? So it's giving the user the ability to choose a color and then click OK or cancel. But we don't do anything with the color. I'm just saying that's all it does, is it makes that thing appear. So we want to store what color they chose. So let's do that. Color, notice the capital C and the lowercase c, color, equals CDB color dot color. Two round brackets. So that line of code, whoops, sorry, no two round lines, my apologies. This line of code stores the color the user selected. So the user would have chosen a color in that dialog box, and it remembers the color. It actually remembers it in a variable. That's actually a variable. It's a complicated variable, but it's a variable. All right, let's go to the next line. Graphics surface equals this dot create graphics. And this one has the two round brackets. Okay, this is actually a very complicated line of code behind the scenes. We don't need to worry about what's going on. But it's creating a surface to draw on. Okay? Because normally forms you can't just draw on a form. But we're saying, you know what, I want you to make a surface on my form that I can draw on, that I can create graphics upon it. Okay? For those of you who think with the word surface, I'm talking about that Microsoft computer thing. No, that's just the same name. That's all. All right. So we've got the surface that we can draw on. So let's use the surface. Surface dot clear. But we're going to clear it to a specific color. Color, oops, that should be a capital C, dot black. Because we want to keep things black. So every time we clear the screen, we want to clear it off to black. We don't have to use black. We could have used a different color. If you're into pink, go ahead and clear it to pink, whatever you want. But that's where we're going to get started. Okay. You guys seem to be following good. That's good. Here comes the next line. This one's, again, a little more complicated. Pen equals a new pen. Okay, so we're going to create a pen, and we're going to use color.white, because we have a black background, so we have to have white on black, comma 1. It's going to be 1 pixel wide. So this is a pen for drawing. Now, in addition to the pen, we're also going to create a brush. Brush equals a new brush. And actually, no. The way we do this is we say brush equals a new solid brush. There's actually different types of brush. And for that, we're going to use the color that the user chose. Okay, so this is, again, kind of a complicated line. Right here, notice the lowercase c for color, because that's the color that the user chose out of the dialog box. The brush is the way the computer fills in a color. It uses a brush. So it's sort of like the paint can in Photoshop. It will fill in a color. Okay, so all those lines we just typed were all about graphics. In no way should you understand those lines. They're just lines you can mimic if you want to play around with some of this graphics type stuff. But now we get into code that's going to look a little more familiar. Int size, that's an integer, equals int. That's, if you anyone remember what that's called when you put it in brackets? We learned it way back in variables. Starts with a C. It's okay. It's called casting. Nud size dot value. Whoops. Value. There we go. So what I did there is I read the size out of the numerical up-down. Now, this is similar to the way you do it in a text box, but in a text box you'd have to do the convert to int32. So with the numerical up-down, it's actually a little bit easier. You just say, hey, take the number out of the up-down, convert it to an integer, and stick it in size. Gotcha. Int move, which is the amount I'm going to move, equals that size plus a spacer. This is how much I'm going to separate each of my graphics by. Int, and I'm going fast because we're running out of time, maximum y, so this is the y value, equals form example2 dot active form dot height minus size minus spacer. Okay. Again, I apologize that I'm going so quickly, but I want to try and wrap this up before the bell rings. I will then repeat this line of code, but instead of max y, I will create max x. And the only difference is right here, this changes to width, not height. So x and y are based on height and width. Okay, so wasn't this a looping example? What? Well, it's time, kids, for the for loop. For int y equals spacer, semicolon, y is less than or equal to max y, y plus equals move. So it's a fancy for loop, but that's what it's going to look like. And again, I apologize that I'm typing so quickly. Now, here's where it gets even more complicated. Inside this for loop, we create another for loop. Does anyone remember what that's called when you put one thing inside of another? It starts with an N. Very good, nesting. Int x equals spacer. X is less than or equal to max x. X plus equals move. So it's basically the same code. Whoops. And then my curly brackets. So there's the nested for loops. Inside those two for loops, the last two lines of code of this example. Surface dot fill ellipse, bracket brush, comma x, comma y, comma size, comma size. Again, I apologize that I'm typing so quickly. And then the last line, surface, oops, dot draw ellipse. There's a difference. Pen, comma, x, comma, y, comma, size, comma, size. Okay, I know that was fast, but I want to show you what it does. Okay, because I think it's pretty cool. So let's run this. There it is. I'm going to set the up down at around, I don't know, let me zip it up to about 90 and hit the plus. And I'm going to pick yellow and click OK. Ready for the magic? Magic. Now I'm going to try taking that up a notch. Let's go from 90 to, I don't know, and I can type in this, by the way. I don't have to just scroll up. 500. I'll hit the plus, and this time I'll pick this purple. Look at that. Now I'm going to drop this all the way down to 1, and I'll pick white, and there's 1. Okay? It draws lots of circles. 100 plus, pick the color. There's that. What the 100 represents is not how many circles it draws. 100 represents the size of each circle. So by the way, if you max this thing out, which I think it maxed out at, what was it, 1020 or 1030? 1030. And I try that. Guess how many circles it's going to draw? 1, because that's all that can fit on the screen, right? That's the example. Okay? This is all in the notes. So if you look in the notes, it's all the codes in there. Okay, so I know I rushed at the end there to get it done. It's all in there though. It's all in the notes. And that's part 2.